We dug into forever and found something that shouldn't be waking up. A block of Siberian permafrost was sliced open, and under a microscope a giant virus, dormant for tens of thousands of years, started to infect an amoeba. It moved. It replicated. It behaved like life waking from a sleep no human had ever seen. That moment rewrites what frozen really means. Ice isn't just a time capsule of bones and pollen. It's a deep freezer for entire ecosystems. Viruses, bacteria, spores, fragments of DNA. Some of it is familiar. Most of it is utterly alien to our immune systems. How did they survive? The cold is brutally efficient. At sub-zero, chemical reactions crawl to a halt. Microbes enter a state like suspended animation. Giant viruses wrap themselves in protective shells that act like armor. And then the soil itself locks them in, preserved for millennia. It's like putting a library into a vault and walking away for an age. Scientists have pulled several of these sleepers back into the light. They gave names to the giants, Pithavirus and Malavirus, creatures so large they could be seen with ordinary microscopes. They never infected humans in experiments. But the fact they came back at all shattered a boundary. Ancient pathogens are not just history. They are potential visitors. Now imagine that vault opening faster. The Arctic is warming 3 times faster than the rest of the planet. Permafrost that has held life in stasis for 10,000, 20,000, even 30,000 years is melting. Ancient soil slumps into rivers. Meltwater carries old microbes into new ponds. Ancient DNA mixes with modern genomes. It's an ecological reunion nobody invited. This is where curiosity turns to tension. Buried bacteria can carry ancient antibiotic resistance genes. Viral fragments can recombine with modern viruses. Dormant spores could revive in new, unpredictable forms. The rules of modern disease were written by an environment that never expected these ancient players to show up again. But this story isn't just fear. It's wonder. These revivals teach us about evolution, about the limits of life, about how resilient and how strange biology can be. They open doors to enzymes that survived ice ages, to genetic blueprints from ecosystems that existed when humans were hunters with stone tools. So what do? We watch, we study, we prepare. We map the frozen library before it melts further, and we ask better questions about how human-driven warming is reconnecting epochs. If a single cell can sleep for tens of thousands of years and wake up, what else is hiding in the planet's deep freezer? Follow for the next episode where we dive into the microbes that built entire landscapes and the one discovery that could change medicine forever. Hit subscribe and don't miss it.